Good morning. Long time no see. So we are back. We finished our unit on quadratics, and I am ecstatic with the level of effort you were putting forth and what you showed me you understand. And it's okay that you still might be a little confused, but trust me, you are way ahead of where you need to be. So we're going to keep pushing forward in this last few 4 weeks or so of school, and I'm going to cover polynomials. You'll be going over this next year, no matter what, and hopefully when you see this next year, it's going to be super easy for you. That's the whole point of this. So first things first, you might be a little confused in the first couple days, so by next week I'm hoping you get a grasp of this stuff. So again, do not feel overwhelmed if you are still a little lost or confused. So just show up to class every day at 1 o'clock. I'll be here, and I will help you with whatever your needs are. So first things first, polynomials. A polynomial, you've been working with polynomials with linear functions, with exponential functions, with quadratic functions, with all sorts of functions. And you just haven't heard that term yet, but you're going to start seeing that a lot throughout this unit. So polynomials can contain multiple variables and a variety of exponents, but the exponents must be positive in order for it to qualify as a polynomial. Now, another example is, for instance, 2y squared plus 7x divided by 4 is also a polynomial because 4 is not a variable. However, 2y squared plus 7x divided by 4 plus x is not a polynomial because it contains division by a variable. And we're going to do division of polynomials later, but I want you to understand, this particular example is not a polynomial because this is not one variable. I can divide polynomials, and we'll learn that later on, probably in the next couple weeks, how to divide one variable polynomials. And it's a lot of work, and it's difficult, but again, you cannot divide these ever because I have a y variable and an x variable. So this would not be considered a polynomial of one variable. So now this takes me to a couple of things I'm going to do with it. All right. I'm not going to pause today either. Can't prepare for you guys. So like for instance, polynomials in one variable literally can only have, you guessed it, one variable. All right, that's an R. For those of you that are critiquing my handwriting, I'm trying to get through this fast for you guys. For instance, something you guys are used to, we got 4x squared plus 2x plus 1. Well, this is a polynomial, so this is a polynomial with degree 2. Okay? We know this follows the rule of polynomials in one variable because it only has x. Yes, we know this is a quadratic, but let's get more specific with the language you're going to see from now on. So this is a polynomial of degree 2 because that is the highest degree, okay? It's always identified, the polynomial is always identified by the highest degree, always, okay? And it's also its leading coefficient, I misspelled that, but I don't care. Its leading coefficient is 4. Now let's be weird. Now let's be careful. All right, a little side note for this. Let's say I had a polynomial like this. 3x minus 5x squared plus 3x to the third minus 2x squared. Plus 4, let's say, plus 2x to the third power, okay? So that's kind of a hot mess, and I did this on purpose because a question might ask you in the future, what is the degree of this polynomial and what is the leading coefficient? Well, you must always put this in normal form, and normal form means in order from greatest degree to smallest degree. So now you must combine all your like terms, and your like terms are now identified by the powers or the degrees they share. So let's combine our like terms in order from greatest to smallest. So in terms of greatest, I got my 3x squared, sorry, my 3x cubed and my 2x cubed. Those are my like terms, so they both have power 3. So when I combine those, this is now 5x cubed. You can see that perfect. I have squared goes next, and that's negative 5 minus 2. That's negative 7x squared, and then just plus 3x. So I have combined all my like terms of this polynomial, and now I've written this in normal form because now I can easily see what's the degree? Well, my degree of this polynomial is 3, because that right there, okay? Leading coefficient. The leading coefficient is the number that is in front of the power of the polynomial, not the one that's in front, because if we just do this, oh, the leading coefficient is 3 because that's in front. No. The coefficient that is in front of the highest power of that polynomial is considered the leading coefficient. So the leading coefficient is 5. So get in the habits early on of writing your stuff in normal form because it makes things easy, and you're going to see a lot of questions about rewrite this normal form. Rewrite that. You know what? I need more coffee. That's cup 1. Wait till you see me at 1 o'clock. I'll be on cup 3 or 4 by then. Hopefully this is making a little sense and it's coming along because we've been doing this for a while. I explained that. I explained this. Oh, let's do this now. So alright, so if I got a polynomial, I'm going to give you guys a lot of examples, similar to what you'll see in today's work. So f of x equals 2. Well, guess what? This is a polynomial. Even though I don't see any variables, I know there are invisible variables there because the invisible variable that's there that I don't see is actually x to the power of 0. Because anything to the power of 0 is 1. So that's why we know this is a polynomial, because that's really there. We just don't see it because anything to the power of 0 is 1, so the degree of, and remember this was originally like this, so your degree is 0 and your leading coefficient is 2. It's as basic as that. On the same notion, we know all linear functions have a power of 1, so don't be, when you see something like this, don't be alarmed. We know 3x plus 2, so we know the degree of this, again, gotta get this in your heads. There's an invisible 1 above that. So there's our degree 1. Our leading coefficient is 3. Hopefully that makes a lot of sense now, and you guys get the hang of that. I explained that. Oh, the last thing I want you guys to do, you're going to see some questions today in today's work about, like, what do the shapes of graphs look like between, odd and even polynomials. I'll give you guys notes on today's lesson to make sure you guys use Desmos. I want you guys to play with Desmos and just plug in random. Try, what does y equal x squared look like? What does y equals x to the third look like? What does y equal x to the fourth? What does y equal x to the fifth? So the even graphs have something in common, and the odd graphs have something in common. And if you wanted to do a coefficient in front of them, be my guest, but make sure they're positive so they're all in the same area type of thing. If you want to do 2, fine. If you want to do 1/3, be my guest. I don't care. It's not going to change anything. If you want to add something to it, or subtract something to it, or add, 5, doesn't make a difference. Just play with it, and you'll see the shapes of the graph all have something in common. Again, you're going to use Desmos for that. Now, let's get to the hard stuff. So, you're going to see some stuff today, and we've touched on this briefly with compound functions. Alright, so I got t of x equals negative 3x squared minus 2x plus 3. That's my one function. My other function is going to be p of x equals 3x squared minus 2. And again, these look like something you saw today. So I want you guys to evaluate all of these functions. We'll do one here, we'll do one here. What's this one going to be? This would be 4 bracket p times 2a, close bracket, And then I'll do the third one in a minute, but I'll show that one. So I'll just do these two right now, and then I'll get back to the last one I want to do, which is the hardest one of them all. If this was a number such as 2 or -4 or 6, doesn't make a difference what it is, you should know by now to just simply substitute this in place of x and solve. Well, now I gave you a little more challenge. I said, I want to know what this function is when x is replaced with a to the power of 3. So literally go into the equation and just solve it with a to the power of 3. So now I'm going to do t of a to the power of 3, that's the input, remember, input, is -3 times, replace x with a to the power of 3, and this is still squared, don't forget that, minus 2 times a to the power of 3 plus 3, okay? Now remember the rules, this, a power to a power gets multiplied, don't forget that. So now I got t of a to the power of 3 equals -3a to the power of 6 minus 2a third plus 3. It's as basic as that, and you have just evaluated this polynomial as such. Do not forget the rules of raising powers to powers. We went over this in the past. Now I'm going to do this one. Okay? So I'm going to multiply 4 times this function after I replace x with 2a. So pay attention to detail. This is where this unit can really hurt you if you're not paying attention to small detail. So I got 4 times, I'm inputting the 2a for x. There's only one place to put that. So now this is 3 times 2a squared. Remember, this is squared, so I got to put that power above that, and you'll see what's going to happen in a minute. All right, and I close the bracket. Now remember, I distribute this power to everything on the inside. So now this says 3 times 4a squared minus 2, close brackets, okay? Now, again, just go through the motions. 4 times 12a squared minus 2, and now these brackets act as parentheses, okay? So I just distribute this 4 to both these terms in here. So your final answer is 48a squared minus 8. And again, it's as basic as that. Now I'm going to show you a third way to do something, and you'll see this in today's work. So again, I'm seeing if you have questions. I'm expecting there to be confusion on my last question, which is right now. Let's say I had, this one says -2t, what did I say, times a minus p a minus 1. All right. I'm going to go into this function, and I'm going to replace a with, I'm going to replace all my x's and only the t of x function, because that's what it says to do, the t of function. Replace x with a. Okay, very basic, very easy. -2 times -3. Remember, this is, I'm multiplying this 2 times this entire function after I input a for everything. So this is now a squared minus 2a plus 3. Now I got to do minus. I'm inputting a minus 1 for x, okay? A minus 1 for x. So now this says minus. Now I'm putting this in parentheses because this says minus right here. I know when I have a minus, I got to put the entire expression in parentheses because at the end, I'm going to distribute this minus to everything on the inside, okay? You got to be aware of that. So now this says 3 times a minus 1 squared minus 2. Now, you got to remember that because I have an expression in here, this does not say 3 times a, this says a minus 1. When I have an expression of plus or minus, this has to expand out into a minus 1 times a minus 1. So I'll do that in a minute. Or I could do this right up here if I want to. All right, just so I can kind of keep my work clean. So I know this means the same as a minus 1 times a minus 1, and we already got through our unit. You know what? I need some more coffee. We got through our unit on quadratics, and that's why I purposely did that first, so that this would be a little more simple. Apply those common rules. So now this is a squared minus 2a plus 1. So watch what's going to happen in just a minute. I'm going to do this now. Distribute this -2 across this entire function right here. So now this says 6a squared plus 4a minus 6 minus parentheses. I know that this is now 3 times a squared minus 2a plus 1, because I've already expressed this out into this, minus 2, close parentheses. Again, take your time. I'm not going to mess with this just yet. Okay, I'll just rewrite it down here so I'm staying in line. Plus 4a minus 6 minus. Distribute this 3 across all of these terms in here. So this now says 3a squared minus 6a plus 3 minus 2 underneath this. Okay? Well, I know that 3 minus 2 is just 1. I'm going to help us speed up our work a little bit. So I can just go ahead and do that. You've already seen this. This is plus 1. Alright? Now, distribute this negative across everything on the inside here. So now this says 6a squared plus 4a minus 6 minus 3a squared plus 6a minus 1. Last but not least, I have to combine my like terms, and your like terms are based on similar powers. So 6 minus 3 is 3a squared. 4 plus 6 is plus 10a. Negative 6 minus 1 is negative 7. So we have successfully done this math applied to these polynomials to get this in most simplified terms. You've got to get comfortable with simplifying stuff. And don't forget also in today's work, the amount of times, let me erase this and we're all finished. Again, we went over this in the past, and I'll just give you some examples so you guys remember this. A quadratic, for instance, right? Quadratic we know is always y equals x to the power of 2. This power 2 tells us that we can have as many as 2 possible solutions. A possible solution means that it touches or goes through the x-axis at least once. So for instance, this would be considered a quadratic, well, because we know the shape of the graph, but also because it touches the graph once. But this is also a quadratic because it goes through the x-axis twice. This is considered the number of, the amount of zeros there are in the function. Okay, this is the amount of function. So a graph like this, how many zeros are there? We don't count this as a 0. I count this as a 0, this is a 0, this is a 0. Do not call the graph crossing the y-axis a 0. I will have your work posted, and I will see you guys at 1 o'clock today.